Okay, welcome to the EE 2950 SI session number 11. Today we're going to be looking at charging and discharging with capacitors and inductors. We're going to get started off with some of the concepts. So our concepts are going to start off with our charging discharging equation, which is going to be x of t is going to be equal to x of infinity plus x times 0 minus x of infinity e to the minus t over tau. Okay, and this is the general equation. Now, it's going to change for each other equation that we have. So for capacitor and inductor, so capacitors deal with voltage. So we're going to be concerned with the voltage for a capacitor at a certain time. So VC of t is V of c at time infinity plus V of c at time initial minus V of c at time infinity e to the minus time over tau, where time is your tau is your time constant. Tau is equal to RC, where this is going to be equivalent resistance, and this is your capacitance. And then likewise, if we want to find current for inductors, because they deal with current, we would do I of L t. It's going to be I of L at infinity plus I of L initially minus I of L at infinity e to the minus t over tau, where tau here is going to be L over R. So it's going to be a little bit different, where this will be equivalent resistance and this will be the inductor value. Okay, something that's going to happen a lot in these problems, an element that we're going to see pop up time and time again is the switch, and what a switch is actually do in a circuit. Well, when we first approach a problem, we have to go in with the assumption that we're going to assume the circuit was in steady state for flipping switch. We're going to put unless otherwise stated. We're going to see what that looks like in just a little bit. But we have a few diagrams here to kind of show various types of switches and what they can actually look like. And a switch can either be opened or closed, but you have to know if it's initially opened or initially closed, and then what happens. So let's take a look at this one here. We see that our arrow is pointing this way, and that bar is right there, and it says this is time 0. So what this tells us is that we're going to follow this arrow, and this arrow is going to tell us what we're doing with that switch. So it's saying at time 0. So it was like this beforehand. This is at time less than 0, so or to the left of 0. You want to call it like that. It was closed, and then we came in here and hit it and opened it up. So we can say initially closed, then we come in and we open it. Let's take a look at what this one, the next one out here is saying. We see that we have our blue arrow pointing that way, and we have our switch open here, not touching anything. So this is saying that initially, time less than 0, this switch was just hanging out here. And then at time greater than equal to 0, we came in and hit it, and we close it. This will be initially opened, and then we're going to close it. Let's take a look at the one at the top right. On the one at the top right here, we see that we have our blue arrow up, and then now our switch is connecting these 2 points. So here at time 0, we're going to come and hit it, and at time greater than 0, it's opened. So here, this is initially closed, opened. Let's take a look at the fourth example. Now this one has 2 different points that I can connect to. All right. I'll call the point on the left A and the point on the right B. And what we're going to say is that where there's the solid line, that's where it is initially. Then this dotted line here is going to indicate where it's going. Okay, and it's going to get that way by that arrow. So we can say that initially it is connected to A, then it's connected to B. This is because we hit it and moved it over to B. So, and I'll draw it for you here. So this is for time greater than 0. It's connected to B. Now, the thing about switches is you can have, when you have 2 options, you can have one of 2 things, or one of 3 things actually. So this will be the first option. Second option would be if it's connected to A, like we saw. And then a third option is actually where it's not connecting to either one. So you have A here, B here, and then the switch is in the middle. So it's not connected to either one. Okay, so just be aware of that whenever you have 2 terminals, 2 options for a switch, that you're going to have one of these happening. But what I want you to notice is take a look at the top 2. They're the exact same thing. It's they're both initially closed and then they're opened. It's just 2 different ways of representing the exact same thing. So it can be a little tricky. You just have to visually realize what's happening with it. All right, I think that's it for the concepts. All right, I'll see you in the problems.